Hello and welcome all to section 2, which is Introduction to Binary Number System. This is video 3 section 2 lecture 1, Binary and Decimal. A quick recap of what we have studied in section 1. In section 1 we studied IPv4, which is a 32-bit binary hierarchical system. So that has got 4 blocks and 5 classes, which we are going to study in detail later. This IPv4 is divided into 4 blocks. Each block is called an octet and each octet has 8 bits. Furthermore, it is divided into 5 classes, class A through class E, of which class E is reserved and we cannot use that. Class D is for multicast used by the dynamic routing protocols. Class A, class B and class C are the other classes where we are going to do all our calculations. Let us come back to binary. Binary is computer's native language. Computer understands only binary. Although we use many different languages while using computer, but computer understands only binary because in this system we have got something called interpreters and compilers, and those are the ones who do this translation of high level languages into low level languages. Low level language means the binary or the computer's native language. In this particular, we will keep our discussion very short on binary. So before we dwell in binary system, let us have some calculations in the exponential form with base 2. We do these calculations with base 2 because binary is base 2, where we have got only two values, 0 and 1. Our native number system is decimal, where we have 10 decimal values, 0 through 9. So 2 power 0 through 2 power 7, these are the different values, and I hope that everybody should be familiar with this. So 2 power 0 is 1. We use the exponential formula to get this value. So 2 power 0 means 2 power x minus x. So x minus x is 0. And according to the laws of indices, this can be written as 2 power x divided by 2 power x. Whenever one number is divided by the same number, the result is 1. This is how we get 2 power 0 is equal to 1. Similarly, like any other number whose power is 0, the value is always 1. Even if there is a complex equation and the whole power of that complex equation is 0, we don't need to worry about the calculation of that complex equation. Just look at the entire power, the whole power is 0, so the value should be 1. Likewise, 2 power 1 is equal to 2, 2 power 2 is equal to 4. When I say 2 power 7, it does not mean 2 times 7, it means 2 is multiplied by itself 7 times. That is how we get 2 power 7 equal to 128. Similarly, 2 power 6 means 2 is multiplied by itself 6 times, not 2 times 6. And that is how we get this one, 64. These are the other examples. Binary digits in an octet. Octet means 8 bits and binary means ones and zeros. So these ones and zeros we write in inside the octet. So octet 8 bits, binary is base 2, exponential form. In a 8-bit system, the highest exponential value will be 7. So we say 2 power 7, 2 power 6, so on and so forth until we go to the last bit, which is 2 power 0. 2 power 7 is 128, which we have already seen over here. So these are also called as the face values, or these are the decimal equivalent of that particular binary number. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, this is equal to 255. You can verify it. So when all these bits are 1, or when all these bits are turned on, then we get the value of 255. This is the decimal value. If all these bits are turned off means they all are 0. If they all are 0, then their addition, when we add them, the total will also be 0. So this 0 will be the decimal and this 255 is the decimal. So we find that from 0 through 255, these are the different possible values that we can obtain from a 8-bit binary number system. So if we count from 0 through 255, totally there are 256 values. 0 being the first value, 1 being the second, 2 being third, 3 being fourth, likewise 100 being 101st, 200 being 201st value, and finally 255 becomes the 256th value. So over here we have got 256 different possibilities, or 256 different combinations of writing these ones and zeros. Why do we need to know these exponential values? Let us try to find out the answer for that. Suppose we have a binary system with only single digit. So what are the possible values that we can write this? So that single bit can be written as 0 or it can be written as 1. So we see that there are two possible values, or it can be written in two different ways. Likewise, if we have a two-digit binary system, then both the digits may be 0, both the digits may be 1, or first could be 0, second could be 1, and first could be 1, second could be 0. So we find that there are four different possible combinations, or four different possibilities, or four different ways in which we can write the binary number system with two digits. Likewise, if we have the binary system in 3-bit system, then we have got 8 different combinations for writing these zeros and ones. Similarly, if we have the binary system with 4 bits, then we have this 16 different combinations of these ones and zeros, or there are 16 different possibilities. Likewise, let us make a small table so that we understand this in a pattern way or in a formula way. So if we have 1-bit system, then 2 to the power 1. There are two possibilities. If it is a 2-bit system, then 2 power 2. So there are 4 different possibilities, or 4 different combinations of writing these zeros and ones. 3-bit 2 power 3. So 8 different possibilities. 4-bit 2 power 4. So 16 different possibilities. So what would happen if it is a 5-bit system? So 2 power 5. For a 6-bit system, 2 power 6. For a 7-bit system, 2 power 7. And for a 8-bit system, 2 power 8, which we have already seen earlier. So 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 256. So this many possibilities. As the number of bit increases, with increase in one single bit, the possibility becomes double of what it was previously. With 7-bit we get 128 possibilities. With 2 power 8 or 8 bits we get 256. So 256 means 128 times 2. Likewise 128 means 64 times 2. Similarly 64 means 32 times 2. With increase in every bit, the possibilities double. Because this is a 32-bit system, let us try to see what is the value of 2 to the power 32. So after doing these calculations, you will come to know that 2 power 32 is 4,294,967,296. Now we don't need to remember this at once. We can go step by step. 2 power 0 is 1, 2 power 1 is 2, then 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384, 32,768, 65,536. Similarly, multiply this by 2 to get the next value, which is 2 to the power 17, and so on and so forth. Likewise, 2 to the power 24 will be 16,777,216, and finally we get 2 to the power 32 as over 4 billion. So this is IPv4. IPv4 is 32-bit system. So in this 32-bit system, we have over 4 billion different possibilities of combining these zeros and ones. And this number also represent how many IPv4 addresses can be present in IPv4. That's all in this particular section. See you in the next section. Until then, goodbye. Thank you.